maybe we could talk a little bit more in depth about um, what some of these terms mean in the context of medicine, and an example of each of those terms. So, in terms of AI, is there an applicable example in medicine that we would all understand?
Yeah, so I think medicine has a lot of things that could be considered AI in the sense that there's a lot of, kind of like decision trees of if the person displays this symptom, then, they might have this condition. So you can think of, I think a lot of like, there were like early symptom checkers that are trying to mimic kind of the diagnosis process, and those could be considered AI, even though there might not be anything that we might consider intelligent from a colloquial sense.
Okay. And those would be more kind of human driven, like
Yeah,
problems
so
or
I think
characteristics that they put in.
like historically, and this goes back to way before I was born, there was a lot of efforts to do like expert systems like this, where you would have kind of a team of clinicians translate their knowledge to build some of these systems. You could also do it in a data-driven way where and that would then veer into machine learning, where you could compile a list of all the symptoms someone had over, and there are papers that sort of do this, and then it could become machine learning. But I think a lot of systems are just based on kind of the gut instinct that a lot of clinicians have.
Okay. And then what would be an example of machine learning?
Yeah, so I think machine learning can be used in many different ways. So I think a lot of tasks that the machine learning community sometimes works on is like, predicting patients who might have complications. So, readmission, et cetera, based on, a set of what ICD codes they had or what vital signs and presentation they had. The same is true for example, phenotyping, where there's many different ICD codes that might correlate, many different pieces of structured data that you could combine, given that phenotypes are so complex in medicine, trying to understand, what sets of patients in a cohort is another place where machine learning is often applied.
Okay. And then how about deep learning?
Yeah, so I think the place in medicine where we've seen the most uptake in deep learning is with a lot of imaging. So, chest X-ray interpretation, for example, and that's a place where you can't have a simple model that does well, where you can't really say, if the pixels are especially gray over here, um, and that's where sort of these multiple hops of kind of deep learning really help in the many layers.
Okay. And so I guess going from the difference from a machine learning example to something more deep learning. So when you add imaging, that adds a layer of complexity to it. So that would require something like a deep learning tool to be able to evaluate and assess that.
Yeah, so then when you have something that's like as complicated as imaging data, that's a place where deep learning models do much, much better than something that's more shallow, which is kind of the opposite of deep learning. And there's, certain tasks, another place that's really complex is, tasks involving text. But they really vary on a spectrum of, how much do you need, and it really depends on how complicated the given text task is.
Okay. And then using that text, does that go into the natural language processing as well?
Yeah, so I think basically anything that involves text. So whether we think about, can we understand, I think there's some efforts now to like triage how important a patient message is, or trying to auto classify, certain elements from clinical text. Any of that falls under natural language processing.
Okay, great.